This is IAQradio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your host, Radio Joe Hughes, and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week is episode number 506, and we welcome Dr. Claudette Hanks Reichel. She's with the Housing Resilience. We're going to talk about building science and housing resilience, bringing research to practice. Before we get started, we want to thank our marquee sponsors.
IAQ Radio marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at healthyindoors.com. Particles Plus, engineers and manufacturers feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
And our newest sponsors are the RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLINC.com. All right, let's turn it over to the Z-Man for today's trivia question.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. Congratulations go out to Doug Conan, Aerotech Environmental in Dayton, Ohio, for being first to identify affidavit as the legal term for a voluntary statement made under oath. The IAQ Radio Trivia question for today, Friday, June 8, 2018, has been sponsored by Ideas, the solution chemistry company creating unique solutions to odor removal, surface cleaning, and decontamination problems. Here is today's trivia question. How many graduates were in LSU's College of Agriculture's first graduating class? Back to you, Joe.
Thank you, Cliff. Okay, Dr. Claudette Hanks Reichel is professor and extension housing specialist with Louisiana State University's AgCenter. She serves as the director of LaHouse Resource Center, a public exhibit of multiple high-performance housing solutions, and a hub of extension education programs to advance resource-efficient, durable, and healthy housing for the southern climate and natural hazards. Do we have you on the line, Dr. Hanks Reichel?
Yes, we do. I am on the phone line, but for some reason, Zoom is having trouble launching.
No
even
problem.
Though it worked yesterday.
We've got pictures, so we'll put some photos up, and we'll do the phone interview. It works just fine. Well, welcome. It's great to have you on board. I've been hoping we could get you on for some. I met you probably 8 years ago and down in Houston, and I always thought it would be wonderful to have you join us, so I'm really thrilled to have
I'm delighted to do this, so thank you. Thank you for inviting me.
Our pleasure. Can you tell listeners a little bit about what led to your interest in housing and health?
Well, I tell you, I'm kind of an oddity. I'm an odd sort of professor because I don't teach any classes or do research. I mean, it is such a cool job. I have 100% extension appointment, which means I do educational outreach within my discipline to try and bring research-based information to the public. And I started focusing on housing, in grad school, more as the consumer and socioeconomic perspective. But when I became an extension housing specialist, in the 80s, of course we had disasters. We were doing disaster kind of work. In the 90s, I started doing energy efficient design and construction and retrofit programs, very big successful programs. And then in the mid-90s, started working on indoor air quality. Then around the year 2000, that was when sustainability began to be an emerging issue, and I realized I really needed to beef up in the building science side of it, because that's what pulls it all together and integrates all those things in a systems approach. So, I started learning and following and attending, meetings, and was mentored by some great building scientists out there. And now that is pretty much the focus of our program, and it was really the impetus for developing our LaHouse Resource Center.
And let's talk a little bit about the LaHouse Resource Center. And I was reading a story about you in, I can't remember the name of the publication, but it was a really interesting article, and they talked about how you had, come up with this idea, and then you were presenting it. But if you could tell listeners a little bit about how this all got started.
Well, our chancellor had a meeting where he asked us about our program emphasis and where we thought it should be headed in the future. And, we had to do it in like 8 minutes. So I did my little spiel, and I said, and a hope and a dream for the future would be to do something kind of like the Florida House, which is a similar project that had already occurred in Sarasota, Florida. It's sustainable housing and that integrates all these program areas and creates a real life-size, tangible demonstration and exhibit for people at their teachable moment. Housing is the kind of thing people are only interested in when they're getting ready to make a change. It's not like food or gardening or anything like that. So he actually turned around and said, let's do it. Like, everyone's jaws dropped to the floor because normally in Extension, we don't get to build anything, So I asked him, I said, you have a benefactor to do this after the meeting? He said, no, that's your job, fundraise. So that's what we did. So I had to learn fundraising too. But it was fantastic experience. We engaged so many people from all over the nation for both their expertise and their contributions. And LaHouse was designed and envisioned over years. Its vision statement, kind of its slogan is shape your home to shape your future. And that's really what it's all about. It's not about a house of the future. It's about applying, the building science knowledge and technologies of today to create something, to create housing that has much more benefits than the status quo out there. And to integrate what we decided from early on is we defined sustainability at the time as the balance and integration of 5 criteria, which really translates to the benefits. One is resource efficiency with a big emphasis on energy efficiency. The second one is durability, which encompasses hazard resistance, for whatever the local natural hazards are. The third is health, healthy home. And of course, that includes indoor air quality in a big way, as well as the concept of universal design. And then those are our 3 educational objectives to integrate and balance. But we also added 2 other criteria, that's practical and convenient, because that is the doability and the marketability side of it. So those others can be done in a way to go mainstream. So that was the guiding criteria for creating LaHouse. And we did it as kind of a showcase, exhibit, demonstration house. It's not everything done one way. We show a whole range of solutions to integrate all those benefits, but at various price performance points. So the facility really is 2 buildings, a house and what looks like a garage is really our conditioned, sort of meeting space. And
we have that up right now. We have a nice
and it's
photo
built,
of it up.
Great. And it, we built it with, each wing is a different building system. So we used 4 different high performance building systems that were really well suited to our geography, our conditions, our construction types, and, our natural hazards and our climate, of course. So we have multiplicity of everything, 10 different kinds of windows and doors, 5 different attic configurations, 3 HVAC systems, So we had cutaways and signage throughout and models and exhibits. So there's just hundreds of things to see here. And it has been such a powerful educational tool that we're so grateful we had the opportunity to do that.
Well, as I understand it, while you were in the construction phase, a sudden and devastating event. Can you tell listeners a little bit about that?
Exactly. We were in mid-construction when none other than Hurricanes Katrina and Rita actually, devastated my state. And in that mid-construction phase, it was like, the structure was there with just house wraps and roofing underlayments, and that was it. And,
Wow.
Of course, it held up beautifully during both events, but at that point, you couldn't get a contractor. They were needed by all of the people who were just, we had over 200,000 severely damaged homes, and a third of the housing stock in the state was damaged. So it was horrendous. So we had to shift gears and do our educational outreach, programs and duties to really help people with the recovery, and then contractors were needed elsewhere. So we shifted gears. What we did is we ended up just putting the roofing up, and we left it in mid-construction like that for 2 years, and we exhibited that way because we already had all these hurricane and flood and termite resistant features, and the high performance building systems fully exposed where you could see them. So it was almost eerie. It was at such a perfect stage for the needs at that point. And we did an open house every Friday, and we had thousands of people come through during that 2 years of mid-construction phase. So actually in 2008 is when we went back and completed it.
I see.
And of course, there were challenges associated with that. But one of the cool things is, these storms kind of tested some stuff, and so we got to see, what really worked, and basically, it was unscathed, and then one of the things we did for termite resistance against the Formosan termite is one of the lines of defense is we built the structural outer shell with all borate treated wood materials where there was wood, and that held up fine being exposed for 2 years like that. It did not mold, it did not stain. It was amazing. So that went really well.
We're back on a photo. We have a couple, and unfortunately you can't see these, but the borate construction, I think we've got a couple of nice photos here that show that greenish tint to the wood. Is that talking about there?
Yeah, that they just dye it to make it look different from regular wood. The borates really don't impart a color, but it comes from boron, which is a natural, sort of element that is also used in, borax laundry booster and in insect, low toxic insect repellents. But it's a wonderful, very eco-friendly, very people and pet friendly, low toxicity kind of treatment that provides great deterrence and resistance to termites as well as decay fungi. And it's not really promoted or rated for mold, but it makes the wood less hospitable. So it really, tended to work for that too. And so it's a great option out there. Now you can't use it for your outdoor woods or in ground contact because the borates can leach out. But in the structure, it's just a wonderful solution where we have a really very high risk here. New Orleans is sort of the hotbed of Formosan termites, but those termites are not like normal termites. They can do major structural damage in 1 year, and they're really spreading throughout the South. So it is something I think to be concerned about. And soil treatment, chemical soil treatment, is the only thing our code requires, and that's important and it's needed, but it's certainly far from foolproof and not permanent. so we, one of the things that we preach, which is also important for hurricane resistance, is to have good, multiple lines of defense against those termites.
Sure. What Cliff likes to refer to as the belt and suspenders approach. Cliff, I hear you got a comment.
Hi. A couple of one question and then actually a comment. In the one photo on the bottom, we can see where there's the greenish wood, and we can also see wood which appears to be untreated and which has a black, dark discoloration on it. I'm just wondering why. Certainly there's no visual evidence on the green wood, but why was this other wood not treated?
The interior partitions, one of the things that we demonstrated and used was finger joint studs. So it's an efficient use of our, local Southern Pine natural resource, but without the warpage, that's straight and true. So we use that as kind of a cost compromise where you use your borates on the structural woods, and then the non-structural woods, we left untreated. So I can't see the picture you're seeing, so I'm not sure exactly what you're saying, but the interior woods were not borate treated. And then there were a few elements that you couldn't get borate treated, such as the wood I-beams and the open web joists, some of these engineered wood products. And so what we did is we did a penetrating borate solution spray on the edge, on the 2 feet ends of everything. And actually that has been shown to be like a lower cost alternative that is a very reasonable option, that in fact I think in some other states that's an approved new construction method, where you do the penetrating borate spray on just the bottom 2 feet of all of the lumber in the structure before you continue building, and that provides very good protection as well.
There's probably another benefit that people may not realize is boraxes and borates are excellent flame retardants as well.
Yeah, I mean, that's what's used in cellulose insulation as the fire retardant. And then it has, the added benefits of creating, a deterrent to mold, and then bugs don't like it, either. So it's just a wonderful additive to both insulation products as well as wood.
Do you recall at all approximately what the additional cost was for having the borate treated lumber?
Well, at the time, it was generally available, and I think the cost was about 25% more. But of course, when the recession hit, after that, the market for so many things just sort of dried up, and now it's actually harder to get. I think in many places in the country, but except for places like Hawaii, where they require they require all construction with treated lumber or non-lumber materials because the Formosan termite's so bad over there.
Mm-hmm.
So it's still produced, but it's a little bit harder to get now.
Okay. Cliff, did you have any others?
Nope, good. Thanks.
Okay, I'm looking at what appears to be your foundation, and there are 4 sections to it, and I don't see any vents in what appears to be probably a crawl space. Do you have all?
LaHouse actually has 3 different elevated foundation systems.
Okay.
The main area of the house, like the great room and the main area, is actually a slab cap over a filled stem wall foundation. So, there's the rebar concrete filled, concrete block stem walls, with some areas that, specified by the engineer for structural support, and then it was filled with compacted soil. And then, the vapor barrier, and then the slab cap on top of it. And that kind of system is done a lot in Florida. It's not done so much here, but it's very robust. You don't have to deal with crawl space issues. And, and it's very strong and very secure and so on and so forth. But it's kind of pricey, it's kind of expensive. So we have that as one of the systems. And then in the master bedroom area, and we have the more traditional pier and beam. And in the master bath area, we have, a concrete block stem wall with flood vents. So yes, if you have a crawl space, it either needs to be open, or if it's semi-enclosed, it must have flood vents within a foot of the ground, within a foot of grade, so that flood waters can flow through and not create undue pressures, heavy pressures on the foundation that could cause structural failure.
Gotcha. And I'm wondering, with your attics, you mentioned, I think, earlier that you had a couple different types of attic design. Can you talk a little bit about attic design and what your experiences have been?
Sure. Down here in Louisiana, we don't do basements. And so, the air conditioning system, the ductwork is typically in the attic. And they're typically vented attics, as traditional. And for us, that's kind of the hottest place on the planet, to put your air conditioning system and your ductwork with leaky, poorly insulated ductwork. And so, studies have shown that we tend to lose, 30 to 50% of all our cooling and, some degree of heating through these leaky, poorly insulated ducts in hot attics. So we do have various configurations here. We do have, we show, one of the things we have at LaHouse is we show 4 ways to keep your ductwork within the conditioned space, within that thermal boundary, your insulation and air barrier boundary of the building. One of the ways is with the unvented semi-conditioned attic. And then we also use that as an additional exhibit room in LaHouse, where we show lots and lots of things there. But it is an unvented attic where there are, the insulation is spray foam insulation at the roof line instead of the attic floor. And it has a little bit of conditioning, and then it communicates with the living space. It's not isolated. We keep it leaky between the space and the living space. And so that way we have the geothermal heat pump and all the ductwork, in there. In the other wing of the house, we do have a vented attic. And in that vented attic, we have radiant barrier roof decking as well as the vents. And the radiant barrier roof decking really does a lot more to keep the attic cooler than otherwise. But also, we don't have the ductwork in there. We have a fur down under that ceiling, so that the true ceiling is airtight and insulated, and then below that is the ductwork. So we have some ductwork in a fur down, the upstairs area, and then between the floors of that 2-story section, we have open web joists that allow ductwork to run between them, and we spray foam the band joist to make it insulated and airtight, so it truly is within the thermal boundary, within the thermal envelope. And then so we have a fur down, we have ductwork between the floors, we have the unvented attic, and the 4th way that we show keeping the ductwork within the conditioned space is in the master bedroom. There is a vented attic, but with a metal roof that is Energy Star rated with a cool color pigment that reflects heat waves more than color. So it looks like a dark brown, but it has the solar heat reflectance of a light color. And then that attic is vented, and the floor is decked, and we spray foam under the attic deck instead of on top of it, and embed the ductwork in that spray foam. So that's the 4th way that we do it.
Interesting. Have you any preference now? Are all 4 working well, or did you have one that
they all 4 working well. If you have a 2-story house, the open web joist and running between the floors is really ideal. The fur down, of having like a dropped ceiling, that is that is a pain for the contractor. Because
Okay.
it messes up your scheduling and your sequencing, and then trades tend to punch holes where they shouldn't. So it's really difficult to design that in and get it done right, even though it's not expensive. It's just kind of a difficult challenge. And so in general, the unvented semi-conditioned attic is the most convenient way to do it if you don't have a two-story house. And so that also provides, some added, you can run all your HVAC and system in there where they want to run it anyway. They've got space, to work, and it creates this nice, clean, climate-controlled attic space, which people like. It makes it much more accessible. And then it has some fringe benefits in our part of the country, because no soffit and ridge vent means in hurricanes, no wind-driven water entry into the attic, causing, water damage and problems. So it's actually a little more hurricane resilient, as well. So it costs more, but it's very convenient, it's very effective, and it has some added benefits. But you got to do it right. People don't realize that space does need a little bit, needs to be semi-conditioned. You need to consider it like a closet in your home.
Okay. I've got another, we're going to break for halftime in just a minute here, but before we do,
Okay.
I got a text question from a listener. I want to make sure, did I hear correctly that the structural wood inside the structure was treated with only borate? They aren't using the standard pressure-treated wood on interior construction?
Right. We use borate-treated woods in the shell, in the structural shell of the house. We use borate-treated studs. We use some laminated strand lumber that was borate-treated. We use borate-treated plywood sheathing. And then what we did is we used a spray-applied borate treatment. And even the SIP section of the house, structural insulated panels, borate-treated foam in those SIPs, and then borate-treated OSB skins.
Oh.
But in the interior of the house, we have untreated finger joint studs for the interior partitions, and then the engineered wood joists. You couldn't get them treated, so we just did a spray applied at the ends, 2 feet at the ends of each wood eye joist and open web joist.
Okay. All right. We're going to break for halftime. We'll be back in 90 seconds with today's guest. Very interesting so far. Dr. Claudette Hanks Reichel. We'll be right back.
Okay.
IAQradio would like to thank our association sponsors. The Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them, wolfsense.com. IAQ marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at healthyindoors.com. Particles Plus, engineers and manufacturers feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Okay, and of course I want to mention RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLINC.com. We got Dr. Reichel back on the line here. I got a question on the exterior finishes here. Let's put the house back up. I'm looking at I believe it's the front, the main entrance here. And
I'm finally in Zoom, so I can see what you're showing now.
Okay, great. You've got a couple different types of exterior finishes. Can we talk a little bit about that and the importance and how they've held up for you?
Actually, we have several different ones. At LaHouse is just multiplicity. It looks like a cohesive house, but we actually wanted to use a lot of different, materials and assemblies all the way throughout to show various ways to, achieve those benefits. But here on the house, you can see, we were required to make it look like LSU, to be congruent with LSU's traditional, Italian Renaissance kind of Mediterranean architectural style. And so basically we had to have, arches and tile roofing.
Okay.
So that was built into the design. And as such, the stucco, you see, we actually demonstrate two types of stucco. On the front porch is actually an EIFS, but a water-managed EIFS system. And we actually have cutaways on the front porch so you can see how it was layered. And then the same with the stucco. The two-story west wing is advanced framing. So it's 2x6, 24 on center. So we have 5.5 inches of insulation, between those studs, so we achieve our R19 or 20 that way. So we didn't need exterior insulation, so we just used conventional, conventional cement-based three-coat stucco. But at the time, people were really not handling it right, where you could still have moisture problems. So our cutaways show sloped weep screed, which nobody was using at the time, and then having the two layers behind the real stucco. One is the weather-resistant barrier, and then the second layer is actually a bond break with stucco. So a cutaway shows that, and then right across the corner on the front porch is a cutaway that shows the drainable EIFS system, where you have exterior insulation, but we have vertical, adhesion and a plastic lath instead of metal. So water that gets through it can drain down and out through a slope weep screen. So we show moisture management, which is really important in our rainy climate as well. We also have brick veneer on those two ends, and the brick has mortar dropping. It has systems to prevent mortar droppings from clogging the weep holes. Mm-hmm. And we show two ways to do that, and it's vented at both the top and the bottom, so for really good drainage and pressure relief. Then on the back side, which you can't see in this image, we have fiber cement siding as well. And that is installed over a drainage mat over, on one side over the sheathing, on the other side of foil face rigid foam to add more R value to the 2x4 section. So that middle section of the house, the living room, is 2x4 but enhanced for higher performance. And we do that one way in front with EIFS and in back with the fiber cement and the foil face foam. The left side of the house, kind of the east wing, that's built with structural insulated panels with SIPs that are all bull rate treated. And so, each wing is a different building system. Now, the teaching center, which is the garage building to the left, that is built with insulating concrete form building system. Very robust, very strong, hurricane resistant, energy efficient, and flood hardy. And then it has kind of a synthetic stucco system that is a little more impact resistant. Yeah, you can see the insulating concrete forms top left there.
Yep.
And then the bottom pictures, you can see the advanced framing section going up where it's all stack frame, 24 on center. And then to the top right, that's where you see, the elevated foundation system before the stem walls, before the soil was installed.
Gotcha. Okay. Now I want to we could do this for 2 weeks in a row here for sure, but got a I've got a lot of other questions on LaHouse,
Sure.
but I want to make sure I focus on the resistance, the hurricane resistance, and the fire and flood resistance.
Oh, yeah.
And if you could tell listeners a little bit about some of the features that you're recommending for those areas.
Well, the number one loss from hurricanes is roof damage and the water damage that occurs when the roof doesn't withstand it. And so that should be people's number one priority. And back before Katrina, it was hard to get hurricane-resistant roofing, but now it is readily available. You can get wind-tested shingles. They're architectural shingles, but they're not just normal architectural shingles. They're specially made, and they need to follow the manufacturer specs for high wind in order for it to work. But a Class 8 shingle doesn't cost that much more than another good quality architectural shingle, but it's been wind tested to 150 miles per hour. So that's huge. I mean, that's wonderful and powerful. And so we definitely recommend, Class G or H wind tested shingles, depending on where you are. And then that on top of what we call a secondary moisture barrier. Instead of just your normal roofing felt, use something that because the underlayment under the shingles are really your main water protection, after the big water that the shingles shed. And if you do lose some shingles, that can really help prevent damage. So you can either tape the seams with a roof-approved tape and then use a synthetic underlayment, which is very tear-resistant on top of that, or you can go cover the whole roof with a peel and stick membrane, like it tends to be used for water damming up north. Mm-hmm. And so either of those are very robust systems. And then the other thing that we suggest is when re-roofing, do those things, but also reinforce the attachment of your decking with ring shank nails. Ring shank nails have much better pull-out resistance than either nails or screws, and never use staples to attach that roof decking. So that's the biggie. If you're in a very high wind area, like a coastal area, then of course windborne debris protections are important to prevent broken windows. And the point of a broken window is not to, the point of windborne debris protection, whether it's hurricane shutters or impact rated window units, is to keep from having a big hole. It's not to keep from having a broken window. It's to protect the structure. Because in very high wind events, if you get a big hole from either losing the garage door or a broken window, that's when the wind pressures can build up high enough inside to amplify the exterior pressures and cause structural damage to the whole house. So that's important in very high wind areas. But for most people, the roof is the biggie, and then the second thing are the soffits. A lot of people tend to use just, suspended soffit materials like vinyl soffits, just suspended in a little J-channel. And we recommend structural soffits. They can be perforated, fiber cement or whatever, but structural and fastened to the framing, because those tend to very easily get sucked out or blown in, and then you get tons of water in the attic and ceiling collapse from that. So those are the biggies for wind that I would suggest to people. What
about flood? Let's go over. That was perfect, by the way.
Flood is a hazard that flood disasters happen almost everywhere in the nation, and they are getting worse, and they're more common, and we cannot rely on the flood map, on the FEMA flood map. That is a flood insurance rate map. It is not a really good determination of where floods will and won't happen. We just had, in my part of the state of Louisiana, middle South Louisiana, in 2016, we had our worst disaster in history with flooding of over 140,000 homes. It didn't hit the media much because it wasn't a named storm, but it was devastating. And then last year, the Houston area had, topped it with even more flooding. 70%, about 3/4 of all the people who flooded were not in a flood zone. This
Wow.
happens all the time. So we say don't just rely on that, but if it's any way possible that you could flood, then first of all, if you're building, elevate 2 to 3 feet above whatever the flood elevation is for that cushion of safety. But if you have existing homes, we really encourage doing whatever you can that FEMA calls wet flood proofing, but I like to use the term flood hardy, and because people understand it better. The idea is elevate what you can, like your air conditioning compressor, your water heater, elevate things that you can elevate to avoid damages above the potential flood level, and then use flood damage resistant materials for your finishes, your floorings and so forth. And then the third thing, if you can, is particularly like if you flood once and you're going to restore or you're doing some renovation or something, consider putting things back in a way where it's washable, drainable, and dryable.
Mm-hmm.
The big disaster and issue that we see after major floods is it takes so long for people to be able to get back in their homes because they're all in competition with each other for good contractors and for materials. And then the scam artists and the lousy contractors swoop in from everywhere, and they take advantage of people in their desperation, and they take their money and leave them, with shoddy, unfinished work and their money gone. It's a horrible tragedy. And so that's why, I have kind of been on the speaker circuit lately, really promoting the concept of flood hardy. And the idea there is you have a washable, drainable, dryable wall and floor assembly so that if it floods, flood water comes in, but all you have to do is wash, dehumidify, dry, and then that's it. Move back in. So if you have that kind of system, you don't have to depend on contractors that are in scarce supply and materials that are hard to get, and the huge, huge economic burden that creates. People could get back in their home in weeks instead of a year and a half, like we're seeing here. So that's kind of my, my little soapbox in terms of floods.
And the other question would be on fire resistance. You're going to be doing a presentation for HUD called Wind, Flood, and Fire Damage Defenses. Can you talk a little bit about fire defense?
Right. What we're talking about there is wildfire, because the big disasters that have happened lately have been hurricanes, floods, and wildfire, particularly in the California area. And though, my state, we're not really, a wildfire place. I did work with HUD on their Rebuild Healthy Home book, and so that was included. The biggies, if you live in a place where there could be wildfires, is, first of all, try to eliminate all the combustibles. Don't let, leaves and so forth pile up in your gutters and your roofs. Clean them out, have gutter toppers, and don't use cellulose-based mulch around your home. Try to keep non-combustible kinds of mulch at least, 3 feet surrounding your home. Of course, use Class A fire-rated roofing, but something else people don't often think of is a lot of the risk happens when embers enter into the attic through the vents. And so adding just simple metal screening that is, 1/4 to 1/8 inch, holes can, to any soffit vents and, as well as any, gable vents or ridge vents or whatever you have, can prevent embers from entering in and starting a fire. So those are the biggies. I mean, there are some additional more robust kinds of sightings and things that people can do, but those simple things, can, are something to consider in any place that has any risk of wildfire.
And while we're talking wildfire, we've got a photo of the LaHouse up here. I want to ask a little bit about the landscaping. Maybe you could comment on the landscaping. I can see how this would be more fire resistant. I mean, you've got the stone walls there that kind of would be blocking some of the, and then it's very clean and clear. You don't have any.
Exactly. Now, wildfire really wasn't our objectives, but one of the things that you couldn't really see from the picture is that we don't have flower beds or mulch of any type within 3 feet of the house. We have these rock beds, like decorative, big rocks all around the house. And our main reason for that is so that there's no food for to attract termites to the house.
Oh, okay.
And but it also helps with drainage, so that way we can have runoff from the roof, because we have at least 2 foot overhangs all the way around, and it runs off into the rock beds and it drains easily, and we don't get any splashback onto the siding. And then there's no cellulose material within 3 feet of the house. So it's one of those termite, defenses as well. And it, it helps with everything. People tend to plant right up against the house, and then they have all this cellulose, so it's an attractive termite. And then the mulch over the years build up, and then it creates, a real pathway for termites. And then the plants keep the house wet, and you have more of a mildew issue. So it's just, problem after problem when you plant too close. So we have a lot of plants in these raised beds, and everything's at least 3 feet from the house, with drainage away, and that's, drain, slope and drain. That is kind of just by design, a free way to help prevent problems. And if you have those 2 foot to 3 foot overhangs, everything's going to last longer. Your doors, your windows, your siding, everything will last longer, stay cleaner, and it's an energy efficiency benefit. So hip roofs are more aerodynamic for wind, and they give you nice shade for energy savings and comfort all the way around, and they shed water away. So modest slope roofs, hip roofs, and 2 foot or greater overhangs have lots of advantages.
Well, another advantage, if I'm not mistaken, is you don't have gutters and downspouts, so there's not the maintenance on those. And for some people,
right, we do have some, but they're strategic. We don't need them all around. We actually use gutters and downspouts primarily for rainwater harvesting. And that's one of the sustainability issues. So you can't see in this picture, but there's a cistern to the right that collects rainwater, from that side of the house, which is used for irrigation. And then on another side, we collect roof rainwater, and it goes in a pipe underground to a rain garden out back. So that master site plan was the original master site plan. We've made a lot of changes since then. So, everything's a bit different at this point, but there is, a rain garden that uses some of the water. One of the things that we do is stormwater management, where we try and keep all the water that falls on the ground and not have it run off and contribute to non-point source pollution.
Are you located on the main campus or just off campus?
We are. We're right on the edge of campus. So we're within the campus, but right on the edge. And, oh, man, we have the most awesome location. We were here first, but now this is where all the athletic expansion happens. So since we built LaHouse, the new baseball stadium is right across the street. We're right next to the golf course. They have, obstacle courses and soccer further on, and then they built tennis right next to us on the other side. So, man, this is a super exposure.
I already wanted to visit. Now you really made it tough. I've got to get Okay, we got a couple minutes. Well, we got about 5 minutes left. A little more than that. I've got a couple other questions, and then I got a text question from a listener. I'll do that toward the end here, but I want to make sure I get this question in about the healthy housing course. the essentials of healthy housing. It used to be 7 essentials of healthy housing, and you've added an 8th. And I know you were a part of helping revise that curriculum. Can you talk a little bit about the 8th essential of healthy housing?
The principles, the 8 principles of a healthy housing, originally said, like you said, were developed by the National Center for Healthy Housing, and we have been a partner with them for a number of years. But the 8th one was added, and they call it, thermally controlled, but frankly, nobody knows what that means, in the general public. And so I like to say, instead of saying keep it thermally controlled, keep it comfortable. And what that essentially is that means doing things so that you can keep the housing unit from having extreme temperatures, either too hot or too cold in winter or too hot in summer. And so that means a level of energy efficiency so that people can afford to have healthy temperature and humidity controls, because that prevents hypothermia and heat exhaustion in severe weather, and particularly when the power is outage. So that's what that one's all about. And I think it's important because these days, as we raise the bar of energy efficiency and the codes and the status quo is changing as our homes become tighter and better insulated, more energy efficient. It's the building science side of it is so important to prevent indoor air quality problems. Having a tight home actually allows you to have even better air quality if you ventilate properly, and because you have control instead of just relying on, haphazard leaks. But you need to really understand the moisture and air dynamics as well as the heat dynamics and get it right. There's a much smaller margin of error. It's easier to screw it up. And so energy efficiency and healthy home really do go hand in hand. It can make everything better, but it must be done right.
Okay, Cliff, I know you got a question here, and then I want to talk a little bit about humidity following your question.
Thanks,
Okay.
Joe. Doctor, I'm wondering, you talked about all the different things that are unique with the home and so on and so forth. I was wondering if there's a link online that we can direct people to that, lists the different things that were done in the home and why they were done.
Yes, we do have a LaHouse Resource Center website. I mean, the easiest way to find it is just Google LaHouse Resource Center, and you'll get to the home page. And then on the home page, if you scroll a little bit below, that's just sort of the top banner. If you scroll down a little bit, you'll see 3 portals. One about LaHouse as the resource center, one that's called My House, My Home, which is kind of the entry point to get tons and tons of articles written really for laymen, for the consumer-friendly kind of information. About how to achieve high-performance housing and all kinds of topics. And then on the right is for housing professionals, and that kind of takes to some resources for them and the seminars and the trainings that we offer. But the one about LaHouse Resource Center, if you click on that, then you can keep navigating to the building features. And we also have a photo gallery which shows a lot of the construction features. And another thing I want to mention is we do have a YouTube channel, and in that YouTube channel, we have produced like 7 to 10 minute video about each of the building systems in LaHouse that talks about, its attributes, and you kind of see it go up from foundation, to completion, and why some things were done the way they were done. So you can see a short video, a 7 to 10 minute video on each of the building systems. And then we have one where they're kind of all put together, and plus the foundation system. So those are available as well. And then also in the YouTube channel, we have kind of a playlist of a whole bunch of short videos which serve as kind of a virtual tour guide of LaHouse. And, if you come to LaHouse, we have these point of feature signs, and we have little QR codes on them, which link to these videos, basically of me doing, my tour guide deal, but there's about 40 something of them, and each of them about a minute long. And so, there I am, kind of doing it.
Looks like you're being a tour guide there. We'll put the link, those links into Cliff's blog. Cliff writes a blog for each show, and then we'll run it by you and make sure we have the right links.
Okay, great.
This has been really a lot of fun. I didn't really get to the term resiliency much, although I think the thing you've been talking about is resilience. Can we, maybe we can wrap it up with that, and then I do have a text question from a listener.
Okay, well, resilience has kind of, been my number one gig and my claim to fame around the country these days, because being from Louisiana, I've sort of become the face of disaster. And so, not really the happiest kind of face, but what resilience means to me, the way I define it, is the ability to bounce back quickly after a disaster. And so that means if your home is somewhat, fairly damage resistant, but also put together in a way where it's easy to clean up and restore, that is so valuable. And that's what develops resilience, the ability to bounce back, which means you can quickly get back into your home and resume your life. What happens most of the time is people do not have resilient homes, and then they end up being displaced and having to find other housing accommodations for a year to a year and a half. That's how long it's taken most people to get back in their homes after these recent floods. And their savings are depleted. And even those with flood insurance, have major economic issues, but only about a fourth of the flood survivors even have that. So, that's why I think, one of the things you said, what needs to be resilient, people or buildings. Well, I tell you, if the home is resilient, the person needs a lot less personal resilience to be able to get through it. And so I think that is key. I mean, personal resilience is a personal quality, and I'm not a psychologist, but, but it's tough. It's tough because the stress lasts a really long time, and it's a huge ordeal. I've seen what it does to people, and it's just really sad. So if we could just see the value in investing in resilience, as well as good indoor air quality and energy efficiency, it gives the homeowner the power. It gives the homeowner the control over their future. And that's really what everybody wants.
And before we go, I don't know if we can answer this or not. We'll give it a shot. We're dealing with this is a listener, Joe, dealing with a rock/mortar exterior on a structure that's 7 years old. There are portions of the wall that are leaking, but others are not. The exterior was erected without a drip plane. I'm not sure what the drip plane means. Where the rock mortar is flush with the tile. Okay, there's no drainage plane there. The dilemma is to identify the areas that are leaking to the interior and hopefully avoid removing the exterior at very high cost. Do you think it's feasible to waterproof the structure, or does it have to come off? That's a tough one.
Well, I mean, that is a tough one. It really needs someone to actually do an inspection, see how severe it is. But, I mean, generally trying to do a sealant on the outside, it could provide a temporary help, but it could also, have an effect on, on the ability of the material to, to dry when it does kind of get wet. And so I would suggest if anything were used, it should stop liquid water, but still be permeable to water vapor. And it's ceiling masonry can be an issue for freeze thaw if you're in a cold climate. We don't really have that issue, but other places might. So, I mean, you could try that, but I suspect in many cases, and from what I've seen, from the people who do the forensic kind of work, is generally, it needs to come off.
Yeah.
And that weather resistant barrier and drainage gap, and the flashing, needs to happen. The other thing you want to do is make sure that your interior surfaces are very, very permeable, so that if water that gets in can readily dry through to the inside, and in summertime, where you have air conditioning. So make sure that you just have drywall and latex paint and nothing else on the walls. But, it just depends on the severity of the leakage.
Well, it's a 7-year-old home, too. It seems that might still be, depending on what state you're in, that might still be within the time limit where the builder may have to come back and help you out with that. But
I tell you, one of the most valuable sources of information out there is, Building Science Corporation's website, because they have been, produced a lot of stuff from, Department of Energy's Building America program, but also they just tend to be very generous with their information and articles. So buildingscience.com, www.buildingscience.com, there's a keyword searchable database kind of thing of just hundreds and hundreds of articles on so many topics. And I know, that kind of topic is well addressed. That's Dr. Joe Steebrook, who's, a very well-known building scientist and, kind of a source of where I've learned, most of what I know about moisture and building science.
Yeah, we go back.
Another great resource is the Building America Solution Center. It has been revamped and extremely valuable, user-friendly source on building guidelines and on all kinds of, the whole range of topics. And so Googling, Building America Solution Center, fantastic resource as well.
And I'll add one, the EPA, for this particular situation, the EPA's moisture control guide also would be a good source, but none
Absolutely.
of them. DOE's working more toward solutions to existing problems, but most of the resources are, unfortunately, it's how we should have built it in the first place.
Right. I mean, their program was really focused on, raising the bar in new construction, trying to increase, approaching zero energy, net zero energy, but and they still do. But in the past, maybe 4 or 5 years, they've really added the retrofit. Deep energy retrofit to their research program. And so there's a lot of content relevant to that now too.
Hey, we got started a little bit late. Can you stay an extra minute? I have one more question I'd love to ask.
Sure.
Okay.
Sure.
You're in a hot, humid climate, and I know at least one of our listeners, I noticed John was on, and John Lapotere, and he's real big on supplemental dehumidification. And I'm wondering how you handle, especially during these swing seasons when you don't necessarily maybe need air conditioning, but you do need dehumidification. How do you handle that at LaHouse?
I'm big on that too. The more energy efficient the house, the whole point of doing that is you develop a very low heating and cooling load. So when your house gets very energy efficient, you don't need much cooling in terms of temperature. You don't have the heat gains and so forth. But the humidity load does not diminish by being energy efficient. And so it seems to increase because it's just not diminished like everything else is. And so really you're going to have to do something to add your latent capacity, to add your dehumidification capacity to whatever you're doing. You can't rely just on, a single stage air conditioner to do it like you can in a home that needs tons of air conditioning all the time. you're just not going to get enough run time, particularly in spring and fall, in mild weather times where we're still very humid, but we don't need cooling. And so there are various ways to do that. Here at LaHouse, we show, we advocate the concept of build tight and then vent right. So we do have mechanical, controlled amount and filtered fresh air ventilation. And at this point, we've done it different ways at different times, but right now we have a ventilating dehumidifier, which is sort of the ultimate solution. Mm-hmm. And so we have a high capacity ventilating dehumidifier that brings in the fresh air, mixes it with indoor air, in the prescribed amount, the prescribed CFMs for the house, and then dehumidifies it first and then adds it into, the central system, the central supply system. So that's the configuration we use in the house. In the teaching center, we have kind of a lower cost option. We have just, a flow control system to bring in fresh air into the return side of the air handler, the air conditioner. And then we have a separate standalone portable, but a semi-high capacity portable dehumidifier like people might put in their basements. Mm-hmm. And we just have it on a cart in the foyer, where with a drain line. And so something like that could be put in a laundry room. It could be in a louvered door closet, as long as you have enough circulation space and a drain line and it's not where the noise is an issue, then that provides the supplemental dehumidification whenever it's needed. So when the air conditioner is providing enough dehumidification, the dehumidifier doesn't run. But when the air conditioner doesn't do it, the dehumidifier runs. And so we show a small portable one. We show that one, which is a little step up. And then we have 2 whole house dehumidifiers on exhibit. The one that's being used is a ventilating dehumidifier, and the other one is designed to where it only dehumidifies the indoor air but distributes it in the central air system. So it kind of, catches up to things. And then the outdoor air just has a flow controller and a filter system into the return. So that's the way we used to do it, but we've kind of upgraded to the ventilating dehumidifier. Other options for people are, the truly variable capacity air conditioners, with the variable capacity compressors can provide better dehumidification in the shoulder seasons, but they cost as much as having 2 separate pieces of equipment. Just going with like a 2-speed air conditioner and a dehumidifier, would cost about the same and give you even better control. So, either one can work.
But dehumidification is vital.
But dehumidification is important. So the more you raise the bar of energy efficiency, particularly in a humid climate, the more you need to give attention to supplemental dehumidification one way or another.
Yep. And the tighter you make the building in the first place and more energy efficient, the less you should have to worry about it when it's coming from the outside. We also generate a lot of our own humidity, but fantastic.
Well, you see, that's the major source. In our climate, the fresh air brings in added humidity. So we do need to really control the amount. And frankly, and according to, some others in the building science arena, in our climate, fresh air ventilation should be designed to meet code, CFM standards, but adjustable, so you can actually, adjust it down from that. And if you have good source control, that can suffice. But if you need more, you can adjust it to that level. And so, we encourage and advocate that. In fact, we amended our codes in Louisiana to make sure that, if mechanical ventilation was required, because the air tightness level was to that point, that it be an adjustable system.
Okay, this has been so much fun. I really appreciate you joining us. Cliff, do you have any final comments or questions?
I do not.
I tell you, I want to thank you so much for joining us. And before we go, is there anything we missed that you'd like to add?
Oh, this has been such a pleasure. Basically, I just, the only other comment that I can think of is, when it comes to housing, it's just amazing to me, and it's kind of sad that people will accept the lowest common denominator. Like a codes create a level of quality, but it's like, where else do we accept something, something where the producer says, oh, we've done it this way for 30 years. So that's a reason to keep doing that way. And where else do we accept, the minimum, required by law? We accept that with our homes, and we really shouldn't. So if people just knew that you could get better benefits and higher performance with just, by providing that consumer demand and having a little knowledge, that's our mission. That's what we are trying to do, to help people see what is possible, yet still practical to achieve. We all deserve healthy, resilient, energy efficient homes, and that's my mission. That's what we're trying to help people do through an educational process. And I appreciate the opportunity to be on your program and to help, send that message a little further. So thank you so much.
Well, thank you, Dr. Claudette Hanks Reichel. It was a true pleasure to get to talk to you a little bit more today. I look forward to seeing you in the future, maybe at summer camp or something like that.
Oh, that would be great. I do plan to be there.
Absolutely. All right. Well, this is Radio Joe Hughes saying thanks to this week's guest, Dr. Claudette Hanks Reichel. Thanks again for joining us. And, of course, my co-host, the Z-Man, Cliff Zlotnick, at the controls. John, you got to have faith. Most importantly, our growing group of loyal listeners. Hey, check out the YouTube video we'll put together of this show. Of course, you can get our podcasts on Podbean. And we look forward to seeing you next week. Actually, I'll be coming to you live from the Indoor Air Quality Association's Mid-Atlantic Conference. You can get some information on that from, I'll have to put it in the blog or maybe put something up on the website. Anybody that's interested, that'll be over in New Jersey up at, I think it's toward Princeton. Wei Tang is running that, the Mid-Atlantic Conference for the Indoor Air Quality Association. I think if you just Google it, you'll find it. And then in 2 weeks, I'll be coming to you from Texas. So, Cliff, we got a lot of interesting shows coming up. And at the end of the month, we've got another one. Nick Hurst from the EPA Indoor Air Plus programs joining us. So a great month of June here, and look forward to seeing everybody next week on the next episode of IAQ Radio.
For IAQ Radio, I'm Spike Reel saying thanks for listening.